All right. Okay, so let's get started. Welcome, everybody. Welcome to the Hadoop webinar, which basically focuses on Apache Hive and Pig. And for this, you will need a little bit of Hadoop background.
The broadcast is now starting. All attendees are in listen-only mode.
All right. Okay, everyone. So let's get started now. Welcome to this Hadoop webinar, which focuses on Apache Hive and Pig. We only have an hour or so, we will be cramping a lot of stuff into this hour, covering two products basically. So let's get started. For this webinar, you will need to have a little bit of background knowledge of Hadoop in general. There are quite a few of you, so I don't know how many don't have any Hadoop experience at all, but really these products are for people who understand what Hadoop is. You don't have to understand the technical details as such, but just an idea what Hadoop does and how it works on a very, very high level. Yeah. So just to warn you in advance. Okay. If I can get to the next slide. Okay. So basically, the agenda is as follows. So just a brief introduction about what OSS Cube is and what we do. So you have at least a clue about the company. Then for those who don't have any Hadoop experience at all, just to give you a bit of a background, because this is really required to understand Hive and Pig. So I'll just briefly touch up some of the aspects of Hadoop in general, and then we'll move on to Hive and Pig. Yeah. And after I cover each topic, I will be giving a slide demo of each of the products, so you have a bit of a feeling of what it's like to use the product. All right. So OSS Cube, since we've already lost a little bit of time, so I'll just race over this. OSS Cube basically is by origin a PHP-based organization, but really we focus on open source technologies in general. Yeah. So really we have the largest pool of LAMP certified professionals. We're first center of excellence for Zend. We have offices on 3 continents, in the USA, in the UK, and in India. And we really actively contribute to open source community and really evangelize open source technologies in general. Yeah. So this is basically what we do. We have quite a few partners, and as you will see, all of our partners are sort of in the open source space, Enterprise DB, Drupal, Talent, Sugar CRM, Zend, and obviously Cloudera. Because since about a year, we started a big data practice within OSS Cube, and as part of that, we partnered with Cloudera, and we are currently the only Cloudera training partner in India. Yeah, so providing Cloudera Hadoop trainings, developer trainings, and admin trainings. Yeah, and this is some of the things we offer. So any consultancy, whether it's big data or PHP related or MySQL related, any LAMP stack related technologies. We can talk about integration, building, or general consultancy. So let's move on. All right. So that was in short about us. Also, after this webinar, if you have any questions, just feel free to email us. The emails will be shown at the end of the presentation. Just a little bit about Hadoop first. Hive and Pig are two open source products, yeah, that are part of the Hadoop ecosystem. Yeah, they basically run on top of Hadoop. So in order to understand what Hive and Pig do and what they are, we need to briefly understand what Hadoop is. So for those of you who have joined who don't have much experience of Hadoop, I'll just briefly race through a little bit of background about Hadoop so you have at least some foundation before we move on to Hive and Pig. Yeah. So basically Hadoop is comprised of two components, HDFS and MapReduce. HDFS stands for Hadoop Distributed File System. So this is the file system where you will store your files onto the cluster. And MapReduce is a framework to process the data that sits on this file system. Yeah. It's based on papers by Google. So in the early 2000s, obviously Google was growing very, very fast, and they had a problem with a lot of data, which they can't store, they couldn't process, and so what they did some research into how they can solve certain problems. Yeah, and what they've done, the result of their research, they published in two papers, GFS, the Google File System, which is published in 2003, and the year after they published another paper, MapReduce. Yeah, and the open source community picked this up. Yeah, and what they did is they picked these papers up and implemented these concepts published by Hadoop and hence, published by Google, and hence Hadoop was born. Yeah. So it's a radically new approach to the problem of distributed computing, and it addresses requirements such as reliability and scalability, and mainly scalability, because we have to we're dealing with large amounts of data. We need to be scalable. Yeah, and so the concept is based around a cluster of machines. Yeah, where a node is a single computer, or it can scale out to thousands of nodes. Yeah, it's not uncommon to have a 1,000-node cluster out there. Yeah, and these clusters of machines are based on cheap, unreliable hardware. And personally, I feel this is where Hadoop really shines, is because you can very quickly create your own cluster based on cheap hardware. Yeah. So the core concept is very simple. You distribute your data across all your cluster, across your different nodes. Yeah, and so the nodes will then work individually on the data that sits locally. Yeah, and it will try to avoid to move data across the network. Okay. So HDFS, like I said, two components, HDFS. So HDFS is the distributed file system, and it is responsible for storing the data across the cluster. What it does, when you load your data onto the cluster, it splits it into blocks. Yeah. So if you have like a gigabyte of data, it splits that gigabyte up into data and then distributes those blocks, yeah, those different blocks across your network. So what you then get is that a small block of the whole data set will sit on different nodes, yeah? And each block is then replicated multiple times, yeah? And so this replication is easy because it's sort of very important because it gives you reliability. So if you lose one node, then you don't lose any data because there's some other version of that block sitting on another machine. Yeah. So these blocks are distributed and replicated across your cluster, and that ultimately sort of ensures your reliability and availability. So even if nodes break down, you still have access to that data. So that is basically the file system. Yeah, you can use it as a storage file system just to store your data, and even if you sort of lose some hardware, breaks down, you can still access the data. But now we need to process that data that sits on that file system, yeah, on HDFS. And for this, MapReduce was designed. Yeah. So some of the features that of MapReduce is automatic parallelization and distribution. So basically, it means if I want to process this gigabyte of data, it sort of automatically utilizes different nodes to process that data. Yeah, the programmer doesn't have to be aware on how many computers does this program need to run, where does this data sit. It's all abstracted away from the programmer, and the whole MapReduce framework will utilize multiple nodes to process a single data set. Yeah. There's fault tolerances, even if a machine breaks down and there was a MapReduce process running on it, no problem. The whole framework will start a new task on another machine to continue the work. Yeah. One important factor here to note is if you write your MapReduce programs, generally they will be written in Java. And this is where Hive and Pig come in, but I will go into that a little bit later. Yeah, so typically you will write a MapReduce program in Java. Yeah. So the MapReduce program generally consists of two phases. Yeah, first the map phase and then the reduce phase. Yeah, so each map will work on a separate block. Remember when I said the whole file, say 1 gigabyte file, may be split up in 10 blocks. Yeah, so each map task will process a single block. Yeah. And each map types can run on a different computer because these blocks are distributed across your cluster. So a map will run on a single block on a separate computer, and in that way it can run in our 1 gigabyte file example, it can run 10 map tasks in parallel processing each block of data. Yeah. Can you imagine the scalability difference that if I have only one process processing my 100 gigabyte of our data, or if I have 10 processes processing each 100 megabyte of data, obviously that will be much more faster. Yeah. So this is how Hadoop becomes very scalable, because each task will work on a subset of the data. rather than one task processing the whole data set. Yeah? And so once these mapper tasks are finished, then the reduce phase starts. Yeah? So these are just general concepts. I'm going quickly over them just as a background. Yeah, so you have a bit of a background of what Hadoop does. Yeah. Again, the assumption is more or less that you have a bit of a Hadoop background when you do this, when you join this webinar. Okay, so having said that, we have a Hadoop system, a cluster with HDFS on it. We have a MapReduce framework on top of that, which allows me to process the data, right? But like I said before, typically Java, the MapReduce programs are written in Java, yeah, and not everybody knows Java. Yeah, many companies have PHP developers, like OSS Cube, for instance. Yeah. But we still want to allow our users or developers access and process the data that sits in Hadoop. Yeah. So we want to expose this data in a different way. Yeah. So this is a problem that people have tried to solve. Yeah. So hence Hive. Yeah. So what Hive try to address is, look, we have all these developers, but not many of them know Java. Yeah. On top of that, knowing Java alone is not enough either. You need to understand the MapReduce paradigm. Yeah. We have a 4-day course to cover the whole MapReduce framework. So it's not an easy thing to sort of get your head around, and even after people finish the course, they still have some problems into sort of really understanding some of these concepts of MapReduce. So it's quite a complex and high learning curve if you want to write your own MapReduce programs. Yeah. So this is one of the problems that some of the organizations try to address. Yeah. And so one of these organizations was Facebook. So Facebook by origin is a PHP shop. Yeah. They had many PHP developers and they had many MySQL developers. That was their background. Yeah. And they saw the benefits of Hadoop. But they didn't want to re-educate all of their developers into Java and into MapReduce. Yeah? So they wanted a way for non-Java programmers to access this data that sit on their Hadoop clusters. Yeah? And not only the developers, but there are also other people who don't want to depend on developers to sort of write their programs for them and access. They want direct access without intervention of a developer. Yeah, people like data analysts and data scientists and these people. Yeah, you don't want to have to wait for your developer. So they started thinking about it and they said, look, we have a lot of SQL knowledge. Yeah, a lot of our developers develop with MySQL, so they know SQL. And SQL is very easy to learn language. Why don't we come up with something that allows us to query Hadoop in a SQL way? Yeah, because many people know. So once we can do that, then in one go, you sort of expose your whole data on your Hadoop massively to a much broader, much wider audience. Yeah. So this is how they come up with Hive. Okay, let's start a project that does this for us, and we call it Hive. Yeah. So Hive is also a Apache open source project. So if you go to the Apache website, you will find it as being one of the top projects there. Yeah. So, okay. So what is Hive then? Yeah. So basically, what Hive does, it's basically a translator. Yeah. So you write your SQL statement, and what it does, it translates or transforms this SQL statement into a MapReduce job. Yeah. So you make sure you have Hive installed on your client computer. Yeah. The interpreter runs on your client computer. Like it's much like your MySQL shell, where you have your shell sitting locally. You type in your query, yeah, and then what happens is the interpreter takes that query, converts it into a MapReduce job, yeah, and then submits that job to the cluster, yeah. That job then runs on the cluster and then can display the results back to the user, so you can see the output of your query, or it can write the results back as a file back into HDFS. Yeah. So this is basically what Hive does. Yeah. That's the core concept of Hive. Yeah. There are a few things you need to understand. That Hive, it tries to simulate SQL. So it tries to be as close as SQL as possible, but not all of the SQL works. Yeah. So when you start using Hive, what are the benefits? It is obviously much more easier to learn than Java-based MapReduce. You don't have to know Java. You don't have to know the MapReduce framework. You don't have to know any of these complex Hadoop APIs and all of that. Simply, if you understand SQL, you can very easy, very quickly, you can understand HiveQL, yeah, which is the query language that Hive use. Yeah. So it's, and on top of that, it's much more faster writing a Hive query than it is Java code. I will show an example later on where you can see the difference. Really, in many cases, 9 out of 10 cases, I would even dare to say, you can solve your problems using Hive and really can avoid any MapReduce programs, writing direct MapReduce programs in Java. So, yeah. On top of that, many people already know SQL, and so they can immediately start using Hive. So, just an example. This is what it looks like when you write. You don't have to read it. It's not important what the code there says. It's just to give you an idea of what code you need to write to implement a simple join query. Yeah, and this is a very simple join query. I've not done a bit more complex complex yet. This is the most simplest of joins you can perform. And this is how it's more or less implemented in MapReduce, and this is how much code it will take at least. Yeah, at least. I've even left out some other aspects of it. Yeah. Now, not only is this quite complex, if you're new to MapReduce, it will take a while before you're able to write this kind of code. Not only that, the more lines of code there are, the more chances there are for introducing bugs. Yeah, there are so many lines where you can introduce bugs. There are more possibilities for typos and all of that stuff. So it will not only will it take time to write it, just testing this is also quite cumbersome. Yeah. Now this is if you write a MapReduce job directly in Java. Now doing it in Hive is only this. Just 2 lines of code. Yeah. You see the difference? So basically what's happening is here is that this simple query, what would you prefer? Writing a query like this or the whole 70 lines of code in the other slide? Yeah. So if your data is sort of really easy to access, it lends itself for Hive access, there is really no excuse for using something like Hive. Yeah. So these two lines compared to the other lines. Okay, one thing you need to understand is basically is that Hive is not a RDBMS. Yeah, I repeat, it's not. People think, and they start thinking about databases as well when they start using Hive. Yeah, and there are many reasons why, and you need to understand why it's not an RDBMS. Yeah. So one of the main thing of RDBMS is basically it's RDBMS is generally real time. Yeah. You run your query and you immediately get results. Yeah. What you get is multiple clients, really thousands of clients will access your database concurrently, yeah, querying on the fly. There's transactions, lots of things are there, yeah. This is what RDBMS is built for. Hadoop is not an RDBMS. What it does is just takes your SQL and makes a MapReduce job of it. That's all it does. So in the end, when you run your query, you're basically running a MapReduce job. Yeah. And so what happens is, because of this, a very simple query can take quite some time. Yeah, up to minutes to run. Yeah, and so it will not give you any real-time access. It is batch-oriented. So Hive, basically, if you compare it with RDBMS, generally RDBMS are ANSI SQL compatible, yeah. While Hive is just implements a subset of SQL 92, but in addition, some specific extensions to sort of basically implement some Hadoop specific functionality. One of the things I did not mention during the HDFS Hadoop introduction is that HDFS is generally a write once system, yeah. So it's basically read only. You cannot do updates. There are some ways of doing that around that, but I'll sort of leave that out of this webinar at the moment. But assume that you cannot update any files. So because of that limitation, Hive also does not support inserts, yeah. And I mean inserts in the sense that you can insert new records. It says insert override. What it means basically is you drop the table or you drop the contents of the table, delete the contents, and you write a complete new set of data into that table. Yeah. So this is basically one of the main differences. Yeah. So no updates. You cannot update a record, and you cannot insert individual records. There's no support for transactions. There's high latency, yeah, because a typical query or MapReduce jobs can take up several minutes or more. Yeah. And currently no indexes, but that is sort of something they are currently working on. Yeah. So Hive architecture in general, what Hive does, yeah, it maps a table definition onto a folder. So when you create a new table within Hive, what it does, it creates a new directory in HDFS. And all the data that sits within that directory is considered the data of the contents of that table. Yeah. So the table basically describes the layout of the files, so how this file is formatted. Everything that sits in Hadoop is in the form of a file, yeah, and so you need to tell Hive how that file is formatted. Generally, this will be a delimited file like comma CSV, comma separated, or tabs, or some other delimiters, and so when you have specific formatting, you need to tell Hive how it's formatted so I can sort of interpret it and understand the data that sits within that file. Yeah? And all these definitions of these tables, all this metadata is stored in a metastore. So this is important because when you do a create table, for instance, in Hive, what it does, it basically creates a entry in a repository which is typically sort of in Derby if you do a standalone version, or in MySQL. Yeah, so it stores this metadata in a separate RDBMS. Yeah, so when you do a create table, what it does, it creates an entry in a Derby or MySQL database. Yeah, and then it reads that metadata from that RDBMS. And then once it understands the metadata, it then goes and fetches the actual data from Hadoop, from the file system. Yeah. So this is quite important to understand. If you install Hive, you need to have a metastore. Yeah, and this metastore is implemented in a RDBMS. Yeah. And if you want to share your Hive warehouse, your Hive data store with other people, then it needs to be a central server sitting on your network where different people can access that metastore. Yeah. If you do the default install, then what happens is that metastore will sit on your computer only and will be accessible to you only, and other people will not be able to access that. So this is one thing to keep in mind because it gives you extra administrative overhead. Yeah. So some of the information that's stored is the names, the columns, the data types, where the data is stored, the format of the data. All this data is held in this metastore. Yeah. So how does it work? Well, you can access Hive using the Hive shell. It's a tool similar to MySQL's shell. If you work with MySQL shell or Postgres shell, from the command line you type Hive, and from there on you can then easily and quickly you can then type your queries and run them. Yeah. So I can briefly give a demo. I think that comes now. Yeah. So let's see if I can give a demo. So here I have an instance I'm running remotely on one of my servers. I hope that everybody can see it a little bit. One of my servers I have running a Cloudera one node cluster. So I have a cluster on one computer. Yeah. And I have Hadoop running on it. And this is my command line, and from the command line I can then easily start Hive. Yeah. So this is the Hive shell. Yeah. And from here I can then start doing queries. Yeah. From here, this is another shell. I can see what's in Hadoop. I can say Hadoop fs minus ls. So this will list all the files that I have, all the folders that are on my Hadoop cluster. So I have two different folders. One is a movie folder and one is a movie rating. When you install Hive, it automatically creates a warehouse folder which sits under the user/Hive/warehouse. Yeah. So here you have a folder. It will create this folder. Currently, I don't have any data in it. You can see the folder is empty. So let's go and create quickly a table. So say create table movie. Yeah. And we have in that movie, we have 3 columns. An ID, a name, which is of type string, and a year, which is a int. Yep. And here, this is then Hive specific, which is not standard as SQL. We say how this data is formatted. So row format, delimited fields. So the fields are delimited by tabs, so terminated by a \tab, like that, yeah, and we finish. So now it goes and creates the table. You can see it's created. Now if I go to Hadoop and do an ls again, so a list of what's in my warehouse folder, I do a list, and voila, you can see there's a directory created movie. Yeah. So currently it has created a movie, but if I do a ls of that movie folder, it will still be empty because I have not put any data in it. Yeah. So what I can do is basically, and I need to speed up quickly because not even covered Pig yet, but I can copy data into this folder from Hadoop directly, or I can do it from within Hive. But I have already some data sitting on my cluster, so let's just quickly copy some data into this folder. Yeah. So let me just show. If I now do a select of the table, it will show me nothing. Select star from movie. Yeah. There. It doesn't return anything. So now I'm going to put some data in that folder. So I say Hadoop fs minus cp. So we're going to copy some data from the movie folder and all the files that start with part. We're going to copy into this warehouse. So user/hive/warehouse/movie. Yeah. So I have some data sitting somewhere, and these are called part 1, 2, 3, whatever. And so I'm going to copy them into the movie folder. Yeah. There we go. So if I again do a ls now of the folder, I can see I have now 3 files sitting there. So Hive will now consider this the content of the table movie. Yeah. So now I can go and query this data. Yeah. So I can say select again. So select star from movie, but let me just limit it by 10 because we don't want to get all those thousands of records. Yeah. There. And as you can see, voila, we have some data there now that I can just query using simple SQL. I wanted to show some join at the moment, but I'll just move on to Pig for the moment. But this is an example of how Hive works. One thing you need to know, when I ran this query, it did not basically run a MapReduce job. For the simple reason you can, what it does, if you do select star in any database, if you do it in a normal RDBMS, what it does a table scan and gets you all the data from what sits in that table. Yeah. Basically, what you do here is you do select star in Hive. What you tell Hive is just give me the contents, all the contents of the files, which is a basic file system operation. Yeah. So you don't need a MapReduce job for doing that. So basically, it calls just Hadoop file system command cut and gets the content of these files and displays them back for you. So this is currently not a MapReduce job running in the back. Yeah, but if I were to make a join, and I want to show that, but I think I'll move on to pick for now. If you do a join where you join two data sets, if I were to create another table and join the movie table with this other table, then it will need a MapReduce job and will generate a MapReduce job in order to get the data. Yeah. So basically, that is quickly how Hive works. What I can do is once I finish pick, I can quickly show the MapReduce job in Hive if people want to stick around. So, okay, so that is the quick demo. So let's get back to our presentation. Yeah. So let's get back to pick now. Now pick, at Yahoo, they had similar problems as they had with at Facebook. Yeah. Again, they had lots of developers who did not know Java, lots of developers who but lots of developers who wanted access to this data. So they sort of tried to address a similar need that Hive tried to address. Yeah. Many of them did not have the Java skills or the MapReduce skill set, but still needed an easy way to access the data on that on the clusters. Yeah, and so they started Pig. Yeah, and currently Pig is a top-level Apache project. So you can find more about it on the Apache website. Yeah. So what is it? Again, similar to Hive, what Pig is, it's an interpreter that translates Pig queries into a MapReduce job. Yeah. Again, the interpreter runs on your local machine. Oh, what did I do? Pitch up. Yeah, onto your local machine, and then turns it into a MapReduce job, then submits the job onto the cluster, and then displays the results back, or writes the results back to HDFS. Yeah. Pig queries are written in a different language from what Hive does. Hive uses HiveQL, which is sort of similar to SQL. However, our good friends at Yahoo, they came up with a different language called Pig Latin. They also always have a nice, come up with these nice names. Pig Latin. And then if you write Pig Latin, you write Pig Latin obviously in the grunt shell. Yeah, but we'll come to that later. So Pig Latin, what is Pig Latin? Pig Latin is basically a data flow language, a more procedural kind of language with a relatively simple syntax. Remember, the aim was to keep things simple so people can easily learn it and work with it. Yeah. So basically, what it means by data flow language is that you sort of process the data sets step by step, much like a pipeline. For those of you who are familiar with Unix and Linux systems, you have this concept of pipes. Yeah, so you can run a command, and the command produces some standard out. Yeah, and you can pipe that data that comes out of that first command. You can pipe it into a second command which processes that data and produces some new output, which you can pipe again to another command, etc., etc. So you can chain all these commands, and you have data flowing through these commands. Yeah. So Pig-Latin works in a similar way. Yeah. It processes your queries line by line, produces a data set which you can store in an alias, and you can access the data set again, process it again. And so what you do is almost like refine the output of your query, which for me personally is a very natural way of working. Yeah, and I'll give you some examples later. Yeah. So the concepts about Pig, unlike sort of Hive, that if you install Hive, you need two things. One is you need a sort of metastore which runs on a separate RDBMS, so you need to have that installed, especially when you share your data with other people, your metastore. Yeah, and what Hive also does, it creates a separate folder, or you need to specify a specific folder on the cluster where your data sits and where Hive can locate that data. Yeah, with Pig you have none of that. Yeah, so you just install a Pig client and that's it. Yeah, no need for a metastore. No need for modifications on your cluster or creating separate folders. You just run the interpreter on your machine. It will turn your Pig-Latin scripts into a MapReduce job and submits it to the cluster. Yeah. So from a admin point of view, an sysadmin point of view, it's much easier to sort of support Pig than it is for Hive, because you have the separate metastore which needs to run on a separate server, for which you need to sort of make it reliable and backups and all of that sort of things. Yeah, Pig has none of that. Yeah. So what does Pig-Latin? How is Pig-Latin different? Well, they've come up with these different names for the elements within Pig-Latin. So you have an atom, which you can say is similar to a column in a database, or a field more in database terms. Yeah. Then if we have a collection of atoms, then we call that a tuple. Yeah, which you can say it's similar to a row, but you can have a subset of atoms, not the full set necessarily, yet still called a tuple. Then we have, when we have tuples collected together, yeah, then we call them bags. Yeah, so a set of rows, in a sense, you put them into bags. Yeah. And in this case, I don't want to make the analogy with the table, because a bag is more or less different from what a table is in this aspect. Yeah, it's just a subset of your data. And then, so basically, the way a Pig script runs is you start your Pig script and you start loading your data set into bags. Yeah, and then you can create new bags as you modify or refine your data set. Yeah, this is how Pig-Latin works in the data flow. You create a bag, then you perform some operations on that bag, which produces new output, and that new output you store in a new bag. Then you do some processing on that bag, and the output of that you process, you store in a new bag. Yeah, so in that way you flow through all your operations. until you ultimately get your final result set. Yeah. So some of the features of Pig, again, joining data sets, grouping data. You can extend the language using UDF, user-defined functions. Yeah. These can be written in Java, but don't necessarily have to, and many, many more things. Yeah. Similar functionality that Hive exposes, you can get in Pig. And again, Pig queries are much more simpler than MapReduce jobs. So this is what it more or less looks like when you start working with Pig. You will start up the grunt shell. Yeah, pigs speak Pig Latin in the grunt shell. It all becomes clear now, I hope. So you start up Pig, you're in the grunt shell. Some of the commands you can use. And from what I also like from Pig is that within your grunt shell, you can use some basic HDFS commands directly from the grunt shell, which is quite nice. Yeah. So you don't have to switch terminals to quickly see or browse your file system on HDFS. Yeah. And it's also much simpler because if you use a different terminal, you need to every time type in Hadoop FS and then your file system command. Within the grunt shell, you can leave out the Hadoop. You just say FS minus LS and then your folder. So it saves you a little bit of typing. Yeah. So this is what a Pig script look like. First thing what you do is, for instance, you load the movies folder. So after load is actually a folder which sits on HDFS, or you can load from local if you have a file that sits on your local machine, not necessarily on the cluster. You can load that. So you load the movies file, yeah, and then you say, okay, this movie files has sort of 4 columns, yeah, and these columns I will call them ID, item ID, rating, timestamp, for instance, yeah. Then I can do a group on them, and notice I do a group on the first bag. So on the left I have a bag ratings, yeah. Then I say, okay, group my ratings by item ID, and the output of that, put them in a new bag, which is called GRPD, yeah. And then I can start processing GRPD and say, okay, for each record in GRPD or each group in GRPD, output the group, the average ratings, and the average rating you name score, and put that in a new bag, yeah. And then for that bag, I then go and say, okay, I'm only interested in the average ratings where the score is bigger than 4.5, so filter out everything else and just leave me those records which have a score higher than 4.5 and put that in a new bag, which is called good movies. Yeah. So this is showing you how you step by step can sort of pick a data set, refine it, process it, filter it, and then output the data. Yeah. And the good movies, you can then decide whether you want the output written back to you in the shell, in the console, or you want the output written back into onto the file system. Yeah. So quick demo. So basically, remember, I've created now a Hive table, yeah. And so Hive table is also nothing more than a file which has sort of a tab separated file, which I can basically use Pig for to query. I can query the same file that Hive works on and use Pig to process that data. Yeah. So let's go out. Let's go back to my remote server. I hope it's visible. It's quite a small console. Yeah. So so this is Hive. So let's just quit that. And so let's start Pig now. Yeah. Again, Pig. I start up Pig, and there you can see. Hopefully, if it's not too small, I'm in the grunt shell. Yeah. So this means I can now start querying. I can do direct file operating systems. So I can say, okay, what I normally do with Hadoop file system operations, I can do directly from the grunt shell. So I can do, for instance, -ls and see what folders I have there. And I can see, oh, I have graph data, movie rating, etc. So these are direct file system operations. But let's start querying now. So say I want to sort of work on the movie data. I can say, okay, let's start with that. So first what I need to do is I create a bag called movies. Yeah. Then I say, okay, load the data from my warehouse. So let's take the data that I loaded into Hive, which sits in user/hive/warehouse, which I think called movie. Yeah. So let's load that data. Yeah. And I'm saying that this data is tab separated. Storage. Yeah, so I'm telling it this data is tab separated. Yep. And then I'm telling it, okay, these are the columns that are in there. So I have a column ID, which of type int. I have a column name, which is of type char array, and a year, which again is of type int. Yep. So this is what I do. So what I do, unlike Hive, where all your data structure is predefined, you do your create tables and all of that. So you create a predefined schema, more or less, yeah, and then start querying it. With Pig, you sort of define this metadata runtime, so on the fly, yeah, which gives you a bit more flexibility in a sense, but at the same time, obviously, it is a bit more code because you need to write these definitions up front every time, whilst in Hive you do it only once and then you don't have to worry about it. Yeah. Sorry, I've made a mistake here. This needs to be equals. There we go. So now we've created a bag, yeah, called movies, which has all my data that sits in this movie folder. Yeah. So I can describe this bag, movies, to let Hive tell me what's it in, and it says, okay, you have 3 columns there, ID, name, and int. Yeah. So I can now say, okay, I want to filter this data. Okay, I want to see the contents of this data, but I only want to see the first 10 rows. Then what I do is I create a new bag, yeah, and I say, okay, limit movies 10. So only show me the first 10 rows, and that's it. And then I can say dump first 10, yeah, which I say, okay, write the output of this query now back to the console. Yeah, so it's processing now, doing some stuff in the background. In this case, it's actually creating a MapReduce process. So it runs a MapReduce program, and as you can see, there we get the output. So this data, all of this here, is the output of my movies file. Yeah. So this is what I've done with Pig. I have queried Pig now. And that sort of concludes the demo. Yeah, and I can quit. There's much more stuff I can show you guys, but really an hour is very, very short for these kinds of things. But this is just to give you a taster, a feel of what is possible with Hive and Pig. Yeah. So I'm sure you guys have asked yourself the question, okay, so what should I be using? Should I use Hive or should I use Pig? I think it's a matter of taste in general. That is one thing. Also a bit of your requirements in a sense. I've sort of put some differences between them on this slide. If you go for Hive, you need to keep in mind that Hive uses a Metastore database, yeah, which is fine if you run alone and you have your own Hive database and nobody else uses it. But as soon as you want to share your Hive database with other people, and it needs to be a bit more available, then you have quite a bit of sysadmin overhead that you need to take care of, and you'll be putting more workload on your sysadmins, which they generally don't like. Yeah. Whilst Pig, none of that. You can just install your own Pig installation on your workstation and start using it without any modifications on your cluster. Your cluster admin may not even know that you're using Pig to run your MapReduce jobs. Yeah. Hive, SQL-like, so many developers will be familiar with it. It will be very, very easy for them to learn it. There are only some minors, but again, you need to be careful that once they start using SQL, they start thinking it is RDBMS and may try to use the data that sits on Hadoop, may try to use Hive as a RDBMS, which it's not. So you need to be very careful there, yeah, that people don't start to think that, oh, we're working with an RDBMS here. Yeah. On the other side, Pig has Pigletten, which is new. Yeah. So people will have to learn Pigletten. They need to get familiar with it. However, it is a very simple language, very easy to understand, and very easy to learn. On top of it, once you grasp the concept of Pigletten a little bit, I find it a little bit more intuitive to work with when you start querying and processing your data. Yeah. SQL is more like a declarative language, so you need to declare things up front and before you can actually test it. With Pigletten, it's more natural way. Yeah, like I mentioned, the pipe mechanism that you have on Unix, Linux, where you can run one command that outputs some data, and then that data goes into a new command, and you start processing it, and so you can refine the output of your process in a very, very natural way. So Pigletten has that mechanism to do that. Yeah. Hive sort of, you can access Hive using JDBC. Again, you need to be very careful that it's not RDBMS, and it will have sort of very, very limited functionality implemented, but it allows you to do that. Pig, no JDBC driver as such. But with Hive also, when you sort of create your Hive database, the structure is predefined. You need to create your tables. You need to specify the columns and the types up front, and the data sets needs to sit in a specific location. With Pig, although it's a little bit more scripting, well, just generally 2 or 3 lines more, but you can do it on the fly, and you're more flexible in defining your data structure, and your data can sit anywhere on the cluster. You just tell it, okay, this is where my data set sits, and use that data. Yeah. So this is basically how Pig works. Yeah. So ultimately, it comes down to preference. From a developer's point of view, personal, I find Pig-Latin a bit more intuitive, although I have many years of experience with SQL. I like Pig-Latin in the way it works. You sort of create a bag, process your data in that bag, the output in a new bag, and in an iterative way, you more or less refine the results. Yeah. So that's basically it. An hour has gone past very fast. Again, I apologize for being late due to some technical difficulties. If you have any questions, you can either type it in the screen, in the chat window, or you may fire off some questions to Rashi at osscube.com or sales@osscube.com. My email address, I just noticed I've not put it in, is Allan, A-L-L-A-N, @osscube.co.uk. So feel free to also fire any questions if you have any.
Hi, Allan. I think they have a couple of questions. I'm not too sure if you could see the question pane on GoToMeeting.
I cannot see
no?
I can't see the questions at the moment.
So maybe I can help you here. Many of the people have actually questioned about sharing this PDF for this presentation with them. But guys, unfortunately, we won't be sharing that in an email with you. The best would be we'll be displaying this webinar on our website. That'll be osscube.co.uk and osscube.in, where you could have access to this webinar. Coming to the set of questions from a technical point of view, I think I'll shoot one by one to Allan. The first question is from Sonam Jan, and she's asking, can we store Pig output directly in Hive warehouse other than using HCatalog?
Yes. Basically, Hive, as long as the data, the output of your of Pig is in the format that Hive expects it. Remember that Hive needs to be the data needs the structure needs to be defined up front. As long as it sort of adheres to that structure and you store it into the specific Hive directory, then Hive will pick it up. That's no problem. Yeah.
Okay. The
next question.
Yeah. Next question is from Jacob, who's asking, could you share the Pig Latin code you wrote?
The script, the load.
Yes, the one that you use in demo.
Yeah. Okay. And yeah, I can do that. How do I do that? Should I do that in the message?
Yes, I think that would work.
Yeah, I need to type it. Okay, let me just take a note. I'll type it in the end of the questions.
And I can upload it
because
in email.
Yeah, I can't just copy paste from my remote desktop.
No, I think I have Jacob's email address. He is registered with us, so I can mail him if he wants.
Okay. Yes.
Yeah.
Yeah, that would be best.
All right, we move on to the another one, wherein Prashant is asking, does Hive has ODBC access?
I know there is a JDBC driver. I'm not too sure about ODBC, but definitely JDBC. So you can connect through Hive to JDBC. I've not seen this requirement for ODBC yet, but I need to look it up. I don't know out of my head.
Okay. The next question is from Bhaskar. Can we use Hive or Pig instead of MapReduce?
It's not a matter of instead. Basically, Hive and Pig, they create MapReduce jobs. So if you run a Pig or a Hive query, it actually runs a MapReduce job. So it's not a matter of instead. It's just another way of creating your MapReduce job. Yeah. So originally, what you would do is write your MapReduce job in very complicated Java code. Now, basically, you write your MapReduce job using very simple scripting language or SQL language, which creates that MapReduce job for you. But in both cases, you run, the ultimate result is a MapReduce job. Yep.
Okay. All right. Can we do everything? That's actually from Pavan Kumar. Can we do everything with Pig apart from Java?
Not everything. 9 out of 10, I would say, cases you probably will be able to solve using Pig. Yeah. So most of the cases, I will definitely, when you have a problem, I would ask myself, can I solve this problem either with Hive or with Pig? Yeah. If not, only then will I refer back to plain Java. And you will see, if you ask yourself this question, 9 out of 10 cases, you will be able to solve your problem with simply Hive or Pig. But there are quite a few cases where you may not, where you need to do very complex operations like graph processing, or maybe you need to do some specific machine learning things or whatever. Yeah. If you have very complex processing that takes place, which is not encapsulated in the SQL, the Hive QL queries or the Pig-Latin, then unfortunately you need to have to fall back onto writing your MapReduce code into plain Java. Yeah, but those cases will be relatively rare. Okay.
Alrighty. We have another question from Rajesh Patala. When can we expect training on Hive and Pig in India? Okay. We have received a lot many requests so far, and we're most likely to get a schedule up and running maybe by the end of this quarter or the starting of the next one. So I think we are most likely to have Hive and Pig training in the end of this year. Okay? Okay, so another one is from Prashant. Can Hive perform everything that Pig can?
I have currently not come across cases which you could not solve in Hive, but you can in Pig or the other way around. Also, both programs, they sort of have the capacity of UDF, user-defined functions, where you can extend the functionality quite a bit. So I wouldn't say that there is a difference in capabilities as such. Yeah, it's just a difference in the way they work, the way you need to administer the way you install them. But capabilities-wise, there's not much difference, no. Okay.
All right. It's again from Prashant. While he's aware about Hive's UDFs are written in Java, which language do you write UDFs of Pig?
Also in Java, but optional also in some other languages. That's not a problem. Yep.
All right. This one is from Srinivas. What about the bags which we have created after loading the results? Can we delete them once our work is done?
Basically, a bag, the way it works is when you create your bag, yeah, it doesn't do anything yet, yeah. It just interprets the line and say, okay, I need to create a bag, yeah. All the bags are actually physically created when you do, for instance, a dump. When you say, okay, now I want to see the data, now I want to run my job, yeah. So then those bags are created on the fly within your MapReduce job, yeah. And so there is no such thing as a persistent bag as such. So once you run your job, then the bag does not exist anymore. But you can still use the reference if you want. I hope that sort of explains the question.
Okay. One question is from Arun, where we have opportunities like which companies have requirement. I'm not pretty sure if I got this question well. It would be great if you could elaborate this. Moving
Sorry,
on.
can you repeat it?
Actually,
so you don't understand. Okay, fine.
Yeah, it's just more of a confusing statement where we have opportunities like which companies have requirements. So are you like talking about Hadoop requirements or MapReduce or, you know, pertaining the same lines in terms of job? So that needs to be
okay.
in Hive and Pig, the opportunities. Okay, I'm still not too sure. Are you looking for a job at the moment, Arun? Okay. Well, if it's about job, I think neither me nor Alan could help you in that case with all companies. But Alan, do you have any idea about the companies that hire resources on Hive and Pig?
I wouldn't say there's a requirement for Hive and Pig as such. It's just general Hadoop knowledge. Currently, big data is really a hype at the moment, really. Everything within IT, big data here, big data there. So basically, what they're looking for is big data experts. And obviously, one slice of the whole big data thing is Hadoop. And Hive and Pig are just projects that sit within the Hadoop ecosystem. Yeah, so it's part of the Hadoop ecosystem. So what you will see is companies will look for general Hadoop knowledge, not necessarily Pig and Hive specific, because if you work with Pig and Hive, you really need to have some understanding of Hadoop as well. So people will be looking for general Hadoop knowledge, and part of your generic Hadoop knowledge, it will be expected of you to also understand Hive and Pig. So that will be the general requirements.
Okay, yep. All right. There is a question from Srinivas. Does Hive support Unicode?
In what sense? Meaning that the data that it reads, if that's the question, then yes, it can read all different file formats, and if your file format is in Unicode, then that's no problem. Yeah.
Okay. Moving on to question from Nasir Sheikh. Does Hive provide any native connectivity? I understand it is not a RDBMS, but it gives JDBC connectivity. This is with reference to the connectivities from standard tools like Cognos, etc. So the question is, does Hive provide any native connectivity?
I'm not on the sure if I fully understand the question, because there are two-way connectivities, yeah? So one-way connectivity is that if you have a system, yeah, sitting somewhere that needs to access data on your Hadoop cluster, yeah? So one way of accessing that data, you can say, okay, I want to access the data through Hive, yeah? So the system can use, for instance, JDBC and directly access Hive through JDBC and retrieve that data. JDBC, by definition, is a native sort of connectivity, in my opinion. Yeah. So in that way, you can sort of integrate system that you have some legacy system using JDBC to query the data from your cluster using Hive. The other way is that you may want to have, say, for instance, on your Hive, in Hive, and the output of that you want to store into some other legacy system or some other database or in your Cognos database, then that's an outbound connectivity. Yeah, so Hive then needs to connect to your other database and put that there. And again, the JDBC connectivity, then you can store the output of your query into external databases without a problem. So again, I'm not sure exactly the question, but hopefully either two ways I've answered it.
Okay, maybe we can add this, anything that is well addressed, as we got the comments from Nasser. But
yeah, well, actually, one other thing,
Sure, Alan, please go ahead.
Hello?
Alan, yes, go ahead.
So yeah, actually, just to add of that, if you mean by native, what you can do is you can sort of embed Hive within your system, and then Hive becomes part of your system. If you write your own system, Java system, you can embed the Hive API, and in that way sort of connect directly to data that sits in Hive. So that is another possibility. So, so yeah, maybe that's what was meant by the question.
Okay, all right. The next one is again from Sonam. It's pertaining to pig latent. How do we generate unique IDs or database sequence numbers other than using UUID in UDF?
Sorry, can you repeat that?
I've mentioned that in the chat script as well for you, Alan. I'll repeat that for you.
Okay.
In pig latent.
I wasn't looking.
Okay.
In pig latent, yeah. How do we generate unique IDs or sequence number other than, yeah, currently maybe in the later versions, I don't know, but currently there's no generator yet. You need to sort of do that currently in UDF. There's no native support for that at the moment, I think, but need to check. But good question.
Okay, and it's in the continuation of the same question. If the data is totally unstructured, say logs where data type is not fixed, is it possible to query it with Hive?
I would say yes and no. Yes, in the sense that you can always say if you have logs and the structure of each row is different, you can always say, look, I load a log entry into a single atom. Yeah, so each line is loaded into a single atom. So and in that way I can just query those log files. So yes, you can. If you want to go and predefine some multiple atoms per line, then it becomes more difficult because once that structure changes, then Pig will become confused, or it may return some results that you might not expect. But in essence, I would say yes. You can always say, okay, the whole line I define as a single atom, and in that way I can query, and if I do some searches through it, I can easily do some pattern matching using Pig Latin without a problem. Yep.
Okay, so we can move forward.
Are there any more questions?
Yes, there are, and it's actually coming in. So
okay.
I will quickly wind up, so, but I think we're left with a few now. This one is from Arun. Can we install Hadoop in Windows?
Yes, you can. Standard Hadoop, Apache Hadoop. You can install Hadoop using Sequin. Yeah, if you use Sequin, you can install Hadoop. Although this question is a bit out of scope, but I'll answer anyway. So yeah, you can install Hadoop using Sequins, and I know Microsoft is working on, I think it's called Hadoop Services or something, where they'll run their own distribution of Hadoop on Windows and Windows Azure, I think. So yes, it's possible.
All right. I think we would take this as the last question from Srinivas. Can we export the data from Hive and import it into another Hive?
Yes, no problem.
You can
just output the data into another Hive table. That is no problem.
Okay, a quick one. With only Pig, can we survive in Hadoop world?
Sorry?
With only Pig, can we survive in Hadoop world?
Yes, Pig will solve most of your problems. No problem.
Okay, I have tried my best to cover all sort of questions. And guys, please bear with us in case we missed any. You're most welcome to send us that an email. It could be rashi@osscube.com. It could be allan@osscube.co.uk. And Allan is ALLAN. Else, for any other queries, sales also is another email address. That's sales@osscube.com. This one is from Rajesh. I would like to do certification on Hive and Pig. Can you please suggest me? I can see certification only on Hadoop developer and administrator. Okay, yes, Rajesh, you could do that. The online certification process is on from Cloudera. But in terms of training and all, as I mentioned, they are most likely to start at least in part 1 training on Hive and Pig, which will be by the end of this year. So we will certainly update every one of you.
Rashi, I don't think there is certification for Hive and Pig as yet. Not yet. There are courses, but I don't know if there's already exams available.
I still need to check with the University of Cloudera because we do have the certification for HBase, the recent training that we conducted with Amandeep, but I still need to check with, because we were discussing internally about this, so I can get back to them.
Okay.
Okay, alrighty. So we have got a lot of, I think, few mails for you, Allan. Most of the people are actually thanking you for the certification that they have cleared after they got the training from you. So that's quite good. Okay, guys, do you have any more questions?
That's good to hear.
Yeah, it is. Kudos to you. Okay, it seems like we do not have any more questions. So, ladies and gentlemen, we would like to end this session now. As I mentioned, for any questions, please feel free to... Okay, it's a quick one. What else we have for big data? I am not too sure if that...
If they have today, the whole day, then we'll be sitting here. More,
and it's even a very broad question. Not too sure if you could cover that.
Yeah.
Yeah, if you could.
I don't. Yeah.
Yeah, Bhaskar,
We'll
actually
be
this
sitting
question
here
is
next week
from...
if we discuss it.
Right. This question is from Bhaskar. So Bhaskar, in case if you could be more precise, we would be better in a better position to address that. But considering the time constraint now that we have, we really apologize. We have covered most of the questions now. Bhaskar, you could please mail us, and we would be more than happy to address that. I think I've received few mails as well in terms of the questions. So Alan, I'm going to forward that to you.
Okay, right.
So now we could wind up finally. I cannot see any more questions coming in.
Okay. Thank
Right.
you everyone for your attendance and for your good questions. It was a
And we
pleasure.
look forward to we look forward to meet you again on the next webinar that we have in the next month. We'll be sending you the invitations and look forward to meet you there.
And that's going to be, by the way, very interesting webinar using MapR and machine learning. So it's a very, very interesting concept. So I really advise to attend if you have the time.
Yep. Okay, alrighty then. Thank you so very much, guys. Thank you so very much, Alan. Have a good day ahead.